Carbon is a non-metallic element. It is found in free state in nature as graphite and diamond, and also in compounds. Let us do some activity. Take silk, wood, fruit seeds, hair, feathers in separate test tubes and heat each of them. What do you see? We observe that slowly their color changes and finally they all turn black. It means they are all transformed into carbon when heated. Thus, we can conclude that all plant and animal products contain carbon as their main constituent. Carbon is found in carbon dioxide in the air, as also in fuels like biogas, petroleum and marsh gas. Carbon has atomic number 6 and atomic mass number 12. Its valency is 4. Now, we shall move on to the properties of carbon. Allotropes. In nature, some elements are found in more than one form. Their physical properties differ, even though their chemical properties are the same. These forms are called allotropes of an element, and this property of the element is called allotropy. Example: carbon, sulfur and phosphorus. Let us study the allotropes of carbon. They are of two types, crystalline and amorphous or non-crystalline. Diamond, graphite and fullerene are the crystalline allotropes. They have a specific arrangement of atoms. Coke, coal, etc. are the amorphous allotropes. The arrangement of atoms here is irregular. Now let us study the different types. 1. Diamonds. They are formed lakhs of years ago by the crystallization of carbon under very high pressure. Brilliant pure diamond is an extremely hard substance. It is a bad conductor of electricity. In the diamond crystal, every carbon atom has 4 atoms of carbon at specific distances around it. If it is heated to a very high temperature, it gives out carbon dioxide. Acids and alkalis do not have any effect on diamond. Diamond is used to cut glass and in drilling machines and as an ornament. Synthetic diamonds are made by applying extremely high pressure on pure carbon and heating it to a very high temperature. 2. Graphite. A graphite crystal is hexagonal. The regular arrangement of atoms in this is in layers. Thus, 6 carbon atoms form a hexagon and are at specific distances from one another. Every carbon atom has 3 other carbon atoms around it at equal distances. The graphite found in nature is black, soft and smooth. It is a good conductor of heat and electricity. Uses of graphite. Graphite has been used for writing since olden times. The lead in the pencil is made of graphite. Graphite is also used for lubrication. In the dry cell, a graphite rod forms the positive electrode. It is also used in arc lamps or arc lights which give bright light. 3. Fullerene. It is a recently discovered allotrope of carbon. The atoms in the allotrope of carbon, known as C60 or buckyball, are joined to each other in pentagonal and hexagonal arrangements. As a result, the structure of the fullerene is like a football. Fullerenes were named after the architect Richard Buckminster Fuller from the kind of domes he had built. The Nobel Prize for Chemistry in 1996 was awarded to Harold Kroto, Robert Curl and Richard Smalley for the C60 form of carbon. Scientists are still making efforts to study the properties of fullerene. It could be used in the revolutionary research related to superconductivity. 4. Charcoal. The most familiar form of carbon is charcoal. It is an amorphous form of carbon. It is produced by burning substances of plant origin, such as wood, in an insufficient supply of oxygen. It is porous and therefore has a low density. Now, let us proceed and study the other properties of carbon. Solubility of carbon. Carbon does not dissolve in any solvent. You can add a piece of charcoal to solvents like water, oil, etc. and try. Let us check the action of carbon with oxygen. When carbon is burnt in air, it combines with oxygen and forms carbon dioxide gas. Now, let us start with carbon compounds. 1. Carbon dioxide. It is found in free state in air. It is given out into the air through respiration of plants and animals. It is found in chalk, Shahabad stone and limestone in compound form. Let us study the laboratory preparation of carbon dioxide. Place some pieces of calcium carbonate, that is limestone, in a flask. Set up the apparatus as shown in the figure. Pour some diluted hydrochloric acid through the funnel. Ensure that the lower end of the funnel tube dips into the hydrochloric acid. We can observe that calcium carbonate reacts with hydrochloric acid and produces calcium chloride, water, and carbon dioxide, which is collected by upward displacement of air. Coming to the physical properties of carbon dioxide. It is a tasteless, odorless, colorless gas. It is heavier than air. It dissolves sparingly in water. We shall try this activity. Hold a lighted candle in the gas jar filled with carbon dioxide. It gets extinguished. We can conclude that carbon dioxide neither burns nor supports burning. Now we shall study some chemical properties of carbon dioxide. When carbon dioxide is passed through lime water, it turns white. Calcium carbonate is white in color and does not dissolve in water. When carbon dioxide reacts with oxides of metals, carbonates of those metals are formed. When carbon dioxide is passed through water, it dissolves a little in it, forming carbonic acid. When carbon dioxide is passed through a solution of sodium hydroxide, sodium carbonate is formed. If carbon dioxide is passed through a solution of sodium carbonate, sodium bicarbonate is formed. You all might have seen a fire extinguisher. Can you tell me why it is used? It is used to put off fire. Now, let us learn its mechanism and working. The fire extinguishers consist of a cylinder filled with a solution of sodium bicarbonate. There is also a capsule of diluted sulfuric acid in it. When the knob is pressed, the acid in the capsule spills on the sodium bicarbonate. Chemical reaction takes place and carbon dioxide is produced, which gushes out of the cylinder. Coming to the uses of carbon dioxide. Carbon dioxide is used to produce aerated cold beverages. It is used to produce dry ice. It is used to extinguish fire. It is used to make washing soda. It is used to produce sodium bicarbonate, that is, baking soda. Plants make their own food by using carbon dioxide in photosynthesis process. Now, we shall learn something about hydrocarbons. Hydrocarbons are compounds formed when carbon combines with hydrogen. Now, coming on to the next compound, methane. Methane is the first in the series of combustible hydrocarbon compounds. The molecular formula of methane is CH4, that is, it has one carbon atom and 4 hydrogen atoms. In nature, it is formed in marshes. Hence, it is called marsh gas. It cannot be liquefied by applying pressure. Hence, it cannot be filled in a cylinder and has to be piped to the places. If methane gas is ignited in air, it burns rapidly with a blue flame. It has great importance as a naturally available fuel. Next, we shall see the production of methane. You might have seen a biogas plant. Which gas is formed in it? We obtain methane in a biogas plant. 1. In a biogas plant, methane is produced anaerobically, that is, in the absence of air, from plant and animal waste. 2. In a laboratory, methane is produced by heating a mixture of hydrogen and carbon monoxide to 300 degrees Celsius in the presence of metal nickel. Coming to the properties of methane gas. It is an odorless, tasteless and colorless gas, lighter than air and does not dissolve in water. It is highly inflammable and burns with a blue flame. When methane burns, it combines with oxygen and produces carbon dioxide, water and heat is released. Uses of methane. It is mainly used as a fuel. It is also used to produce acetylene, another carbon compound.